All right, you are welcome once again to my channel. And again, I have a question that I want to analyze. I want to analyze this question, very, very important. And then this video might be long, but I'll try and reduce the duration of the video because I don't like long videos. So let's just go straight to the point without saying much. Now, if you are writing the UTME examination, there is one aspect of chemistry that you must not fail to look at. And what aspect is that? That aspect is coming from the metals. Now, some people is looking at the metals. You need to look at the extraction of metals. So if you want to look at metals, don't just read the metals. Now, have a goal. Now, what are you going to look at when you are analyzing or checking out metals? Now, you are going to know the method to extract the metals. You are going to know the ores of the metals, and you're going to know the test for the different metals. Now, that is where this question is actually coming from. I know that yes, you have known flame test. I've done it in one of my videos. So if you know this is your best video that you're watching on Mosjaro's page, just go down. You see the flame test where I get to analyze test for what metallic ions and what flame test actually means in testing for metallic ions and which metals give which color to the what to the flame test. Now this is another test again for metallic ions, but this time around we are using precipitating agent. Now you know that it's not about reading a particular question, it's about analyzing the question step by step. So when you come across such questions again, it will be much easier for you to tackle, to deal with. Now, persons writing this exam, now if you know you are going to write this exam, there's a live stream I'm going to do here on my YouTube, which is known as the last straw. Now, that last straw is coming up on the 15th of April, a date to the exam in the morning or anytime you get to watch the video, but I'm going to upload it in the morning now, or rather you're going to watch it live. It's going to be live streaming. Now just get your data ready so that we get to analyze questions on that day live and you get to answer your questions. So get prepared for that class. Is very, very important. It's happening on the 15th of April, a day to the Utme examination, strictly for those that are praying for the Utme examination. Quickly, let's jump into the video very, very fast to the question. They said an aqueous solution of a metallic ion, that means a metal salt. M, they did not tell us. They say it's a metal. Now let me underline it here. A metal what salt M gives a white precipitate. Oh, perfect. Now, ladies and gentlemen, boys and girls, you know how we used to do it. We are not just going to look at, look at the answer to the questions. We have to check out step by step. So if you know you have basic foundation in chemistry that you don't really understand chemistry that much, this is the class for you. Now, before we jump and move ahead, there's what we call precipitates. Let's break it down step by step. There's what we call what? Precipitate. Waiting be a precipitate and is a solid that is formed in a liquid when a reaction occurs. Now look at what I'm trying to say now. Maybe this substance and this substance reacts together. When they react together and there is a liquid, they react in a liquid, for instance. If a solid is formed inside that liquid, it's called a precipitate. Actually, a precipitate is a solid substance formed when two reagents react. Let me use the word reagent. Now, there are some substances that are used as precipitating agents. So I don't want you to get confused. Just know that a precipitate is a solid form in a liquid. Layman way of looking at it, precipitate is a solid formed in a liquid. Though there are some precipitate that becomes soluble, there are some that are insoluble. So there are some precipitate that are soluble in a liquid, so they will dissolve in excess of the liquid. If you look like the question, they're trying to say something like that. That after the precipitate has been formed, if I put excess of the precipitating agent, it's going to dissolve them. I'm not see it again. Though there will be a color confirmation. There'll be a color confirmation that yes, this precipitate has been what has been formed. So most of the time, to test for metallic ions, and you know that metallic ions are usually what are cation ions. Now, what are cation ions? Cation ions are what? Cation ions are positively what charged ions. So there are some reagents. Now let me break it down. There are some reagents that are used. So apart from the flame test, there are some reagents that are used to test for metallic ions. Now, these reagents are known as precipitating agent. Now, I'm going to give you example before we jump into the question. Now, examples of precipitating agent. Number one, we have sodium hydroxide. Now, if you check the question, sodium hydroxide is used here as a precipitating agent. Number two, ammonia can also be used as a precipitating agent. Number three, hydrogen sulfide is a good precipitating agent. This question have come out in the exam. Now, these precipitating agents are used to test for what? Ions, especially cations, metallic ions. What does that mean? That all these agents, they give colorful precipitates. So I go use and say, no, say, okay, this metallic ion there, just like for flame test, the coloration that is formed from flame test, now sodium gives a golden yellow coloration. So metallic ion gives a color precipitate when they react with precipitating agents. Sure, they get them now. So a good example is sodium hydroxide is a precipitating agent, ammonia is a precipitating agent, hydrogen sulfide is a precipitating agent. Again, you must know that hydrogen sulfide is a good reducing agent. Sure, you get them now. That means if all these guys now react with metallic ions, they will form precipitate. Now that precipitate, I can use that precipitate to confirm the presence of this metallic ion. Now, if you check the question very well, you are going to notice that, oh, there's a color that is being formed. So I can use it to confirm it. So I need to check each of the options and check out what they are saying. And remember what I said from the beginning of the video when I was displaying, or rather describing precipitate. I said there's some precipitate that are soluble in excess of the precipitating agent, while some are what? Are insoluble. So now that one, now we will use to really differentiate the metallic what? Ions. Now look at it, because you know why? Most metallic ions forms a particular color. For example, they form white precipitate. Like on the board now, there are some that show that forms white precipitate. So how do I differentiate them? It now depends on if they are soluble in excess of the precipitating agent or they are insoluble. Now there I would say get them. Now look at it. In this particular question, they are using two precipitating agents. You have seen it already. Sodium hydroxide and what? And ammonia. But I'm going to read more, see the color where they form. They said forms a white precipitate if I use sodium hydroxide and it dissolves in excess. So you see now, it dissolves in essence. That means the precipitate when sodium hydroxide they form with the metal now white. The color now white. I'll see white. Now, but the problem is that the precipitate now dissolves. That means it's soluble in excess of the sodium hydroxide. So we don't settle that one come out. Okay, good. Now say with aqueous ammonia, that means aqueous ammonia. So we say they talk. Sure, you know, say ammonia and gas. Now, this video, I want to take my time to analyze it so that it will make sense to you when you would see other questions concerning these. Now, ammonia and gas, when they say aqueous, that means say water go dey. So you get them. And you know, say ammonia is highly soluble in water. That's why it's used in the fountain what experiment. Now, come back, but remember, hold it. There is not only ammonia that is what used in fountain experiment. Hydrogen chloride. Again, number 4, hydrogen chloride, or if you like, hydrochloric acid, can also be used as a precipitating agent. So you get them now. So this precipitation agent, they can be used to test for metallic ion based on the precipitate that they form. Some form soluble precipitate, some form insoluble precipitate, giving out colors. Now, okay, good. We don't establish that knowledge now. Now they said if these metallic salts react with aqueous ammonia, the solution of N also gives a white precipitate, EJ, which dissolves in excess. Good. This is what kills it. I've seen the answer already. This is what kills it. Now, more will come. Sorry, say that they use my hand, but the thing is, say now you must pass this exam. You must understand what you will do. Now we have established that fact. Let's begin to analyze it step by step. Now let me just break it down for you. Not tell anybody. Let me just break it down for you. Zinc, calcium, aluminium forms white precipitate with sodium hydroxide. That's the first thing you must know. Just put that for your head. Now the question will now be, the precipitate formed by these 3 metallic ions, are they soluble in excess of the sodium hydroxide or they are insoluble? Moku check am. But this idiot no go form. So this D is out of it. Do you know why? This copper does not form a white precipitate. It forms a blue gelatinous precipitate. So this one, it forms blue precipitate. You have to hold your pen and book there. This one forms blue precipitate, but the rest of them they form white precipitate. So you don't use ones to not kill many people. Okay, if this fool reacts with sodium hydroxide, they are precipitate now white. But now we need to analyze if the precipitate form will be soluble in SS or not. Oh yeah, come, let's analyze it. Now, first of all, sodium, this zinc, when you have with sodium hydroxide, it forms a white precipitate. What if the white precipitate? Move give the reaction. Zinc plus zinc ion now plus sodium hydroxide. Look at it. It's going to form what? It's going to form, because of this guy, it's going to form what? Zinc hydroxide. Shey you dey get am now. Shey you dey get am now. Now, this zinc hydroxide wey dey here so, na im be the white precipitate. If I react this zinc hydroxide, dey watch me o, this zinc hydroxide now wey don form as a precipitate with excess of the precipitating agent, they say dissolve in excess. Now look at what's going to happen to it now. I'm going to have Na2 excess of it bracket Zn bracket OH. Now you know, so we get 2 OH before for here, but in this 2 come be 4 this time around, 4 bracket close. Now this guy is formed. So you get now this, see what we try to do. This is white precipitate formed when sodium reacts with what? With sodium hydroxide, and when zinc rather react with sodium hydroxide. Now that white precipitate dissolves in essence of the base. Look at the base now to now form this guy. So be very careful with the exam question. You know why I analyze them like this? They can ask you which compound is formed when zinc reacts with excess sodium hydroxide. Might be this one. So when you're preparing for this Utme exam, like I used to tell my students, I said there are some questions that are meant for those that want to really score high. There are some that are meant for those that they get score now to which you want to score for chemistry, for instance, you want to score 60, 50. Those are children's score. But if you want to score high, there are some questions that you need to think about, not cram, think about it. Now look at it. So we have known already that this zinc, but let's now check out with SS, with aqueous ammonia. This is where the whole thing is drawn out from. Zinc also forms a white precipitate. Calcium forms a white precipitate. Aluminum forms a white, but there's a problem now. This calcium is out of it. If calcium reacts with sodium hydroxide, it does not dissolve in excess sodium hydroxide. So this one is out of it. This one is out of it. Calcium does not dissolve in excess of the base. It forms a white precipitate with sodium hydroxide, but it does not dissolve in excess of the base. Show you the get am now. And that white precipitate formed, if it's this guy, if you have with this guy, it will not be what? Calcium what? Hydroxide. Now, this calcium hydroxide does not dissolve in excess of the base. Man can show you the get am now. So if I replace this guy with calcium now, it's forming this guy, and this guy is white. Just like this guy is white too. Now, the problem here is that this precipitate that is white now does not dissolve in excess of the base, unlike this one that dissolves. So calcium cannot be the answer. Copper, because copper gives a blue, it cannot be the answer. So the answer between zinc and what? Aluminium. Now, because both of them forms white precipitate that dissolves in excess. But the problem is that this zinc dissolves in excess of sodium hydroxide and aqueous ammonia, but aluminium do not. Show you the get am now. So aluminium do not dissolve in what? In excess ammonia. So that is where the problem lies. So it's not correct. So the answer is what? Is zinc. So you can see how we are able to analyze. Now you don't put at the back of your mind, say, okay, zinc forms white precipitate both with sodium hydroxide and with ammonia and dissolves in their excess. Okay. This one forms a white precipitate but does not dissolve in sodium hydroxide. This one forms a white precipitate with sodium hydroxide and dissolves in it, but does not dissolve in excess of ammonia. This one does not form a white precipitate. This one forms a blue precipitate. So you don't get to know, okay, I have known now how to use sodium hydroxide and ammonia to test for metallic anhydride, like you have known the flame test. Now, all these things will make you understand chemistry more and know why. Okay, look at what I want you to know. There are some reagents that can be used to test for cations. Those reagents, they call them precipitating agents. I don't give you now examples of precipitating agents, so you don't know them already. Sodium hydroxide, ammonia, HCl, and even H2S can be used as precipitating agents to form cations. Now, those precipitate form most times have colors. Now, these colors used to differentiate them. So, ladies and gentlemen, boys and girls, there are some videos I'll be dropping like this, very technical videos, for you to be able to understand some aspect of chemistry very, 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 very well. Now, there's another one I want to upload right away, quickly, without wasting much time. Now, there's one question that somebody sent to me that I want to quickly analyze very fast, and I want to do it in this video because it's a very short video. They now said, they'll ask me the exam. They said, How many unpaired electron is found in oxygen ion? And this question was giving somebody problem, but there's no problem here. It's too simple. Now, this question is actually a wide objective question. Now, they said, which of these, how many unpaired electrons are there in oxygen? First of all, you know that the oxygen atom is 8. And because it is 8, and you know that number of proton for a neutral element equals to number of electron, yeah? So the number of electron here is how many now? Is 8. Now this one, now this 2 minus, what does it mean? This 2 minus simply means that it has what? It has gained an extra 2 electron. Now, may I just do a sharp time on day? If we have known that, if you do the XPDF configuration of oxygen, you are going to have 1x2, because you know that S can carry a maximum of 2 electrons, P can carry 6, D can carry 10, F can carry what? 14. Now, 1x2, doing for this now, 2x2, then 2p4. But because it has gained 2 extra electrons, here will now be what? 2p what? 6. That means 10 electron is not here. This one is 8 electron. So they say how many unpaired electron. Now for you to do that, either you just go to the last block or you do it according. You know that S has 1 orbital. So to arrange the electron, you arrange them in opposite what direction, according to Pauli exclusion principle. Now you go this one again and arrange it in what? In opposite direction. But when you go to the P, you know that P has 3 orbitals. Now, if you arrange them partially according to Hund's rule, Hund's rule only applies to degenerate orbital. And what are the degenerate orbital? I know I'm very fast, but you have to pay attention. I'm trying to make the video as short as possible. What are degenerate orbitals? Talking about the PDF, they have more than 1 orbitals. P has 3, D has 5, F has 7. That's why an orbital can carry a maximum of 2 electrons. So no wonder P can carry 6, D can carry 10, and F can carry 14. So we are having 6 here. You have to partially fill it first. Then 3 is left. Then you have to completely what? Fill. So you can see that for oxygen ion O2 minus, it does not have unpaired electron. Why this one has what? Unpaired. Why? In the sense that in this situation here will not be 4. But the number of unpaired electron in oxygen ion is what? Is 0. But when is the normal oxygen? Let's do for the normal oxygen, not the ion, the oxygen atom this time around. Sure, you know that this one will come before. Now, if not like that, you can't say, okay, 1, 2, 3. 1 remain, you can't put on. That means for oxygen atom, there are 2 unpaired electrons. But for oxygen ion, there are no unpaired what? Electrons. So do well to share the video as you watch it, and do well to what? To tell your friend, and of course, press the subscription button so I get to see videos like this as the exam draws by. But don't forget the last straw that broke the jam pack. Don't miss it. On the 15th of what? Of April, a date for the exam. It's a live streaming section where you get to ask questions, get to interact with me one-on-one. So get your phone ready, get your MB ready. It's going to be like for a 1 hour, we'll be bombarding ourselves. 1 hour chemistry, 1 hour biology. So stay tuned, don't miss out. Peace. Mosjaro is out of here. Thank you.